Okay, welcome back. Today we will finish Chapter 3. We're going to take a look at Section 3 of Chapter 3, which is dealing with the concept of absolute value as it applies to both equations and inequalities. First, let's talk about what's meant by the absolute value. Okay, that's probably a term that you have heard of before. You've probably seen the symbol that we use to represent the absolute value. Okay, for example, what we're going to have here, the absolute value symbol are these two lines, parallel lines, and we usually throw a number in between them. For example, if we were to take a look at the absolute value of 4, the answer is a positive 4. And that's because by definition, the absolute value is the distance that a number is away from 0 on the number line. And so if we are taking the absolute value of 4, we would be able to say that it is 4 units away from the number 0 on the number line. Another example, once again, we have these absolute value bars. And let's say we were taking the absolute value of the number -2. Okay? Well, the absolute value of a -2 is 2. And once again, why is it 2? Because the number -2 is 2 units. That is the distance that the -2 is away from 0 on the number line. Many times, people just think of the absolute value as a positive number in the end. Okay? It's not the best way to approach it, but it's because it is a distance. That's why your answer will always be some type of positive number. Okay? Now let's see how we're going to integrate the absolute value when it comes to equations. You have learned how to solve so far some different types of equations, linear equations and literal equations, things like that. Now let's take a look at absolute value equations and how we're going to solve them. And we're going to say A is going to be an algebraic expression of some sort, whether it be an x, a 5x, an x plus 2, an x minus 7, some type of algebraic expression. That's what A is going to represent. And C is going to represent some positive constant. Okay? And so our rule of solving an absolute value equation is that if we have the absolute value of some algebraic expression, and if it equals the positive constant, whenever we see something like this, where we have the absolute value of some algebraic expression, and if it's going to equal a positive constant, from the one equation, what we're going to do is we will create two relationships. The first relationship, we merely drop the absolute value bars, whereby we would write that the algebraic expression equals the constant. And then you would solve this equation. The second relationship that you establish is to once again drop the absolute value bars and say that the algebraic expression is now going to equal to the opposite of the constant. Notice I didn't say negative constant. I simply said the opposite of the constant. Those are the two formulas that you're going to create based upon the one relationship. For example, let's do the most fundamental type of absolute value equation that there is. Let's say we have the absolute value of the number of the variable x equals, let's say, 6. Okay? Here we have the algebraic expression, the variable x. We're taking the absolute value on the left side. It equals the positive constant, the 6, on the right. Okay? So we're going to create two relationships based upon the one. The first relationship, basically x is going to equal 6, because that's what it tells us to do here. Set what's inside equal to what's outside. So x equals 6 is one solution. But there is a second. in that the second solution, we take what's inside the x and set it equal to the opposite of your constant. And the opposite of 6 is negative 6. So those are your two solutions to that particular problem. Both 6 and negative 6 are 6 units away from 0 on the number line. Let's try a slightly more challenging one. Not too difficult though. Here we have the absolute value of, let's say, x minus 5 is going to equal the number 3. Here we have our one relationship. Okay, from the one relationship, we're going to form two relationships. The first one, simply write x minus 5 equals the constant 3. The second relationship, we take the x minus 5, and we're going to set it equal to the opposite of 3, negative 3. So now we have to solve these two linear equations for x. For the first one, I have to add, of course, the 5 over, giving us now x equals the number 8 as one solution. The second solution we get by adding the 5 over, and so now x would equal the positive 2. That would be our second solution to that absolute value equation. Let's try another one, slightly more challenging. Let's say we have the absolute value of maybe 2x plus 7 is going to equal to, let's say, the number 11. Once again, what we need to do is we're going from the one equation, we want to set up two equations. The first equation of 2x plus 7 is going to equal the positive constant 11. For our second relationship, 2x plus 7 would have to equal to the opposite of 11, negative 11. Those are the two equations that we have to now go and solve. I begin by subtracting 7 on both sides of the first equation, giving us now 2x on the left, and it would equal 4 on the right. As we go to divide both sides by the number 2, to get x alone, we get x equals 2 as one solution. To get our second solution, I have to once again subtract 7 on both sides. That would give us now 2x on the left and a negative 18 on the right. As we go to divide both sides by the positive 2, we now, of course, get x equals a negative 9 as our second solution. Let's try a slightly different one. Okay. In the first couple of examples that we did, okay, the absolute value is already by itself on the left side. The absolute value of x minus 5. The absolute value of 2x plus 7. That absolute value is isolated. But let's say we have something like this. The absolute value of maybe x minus 6 plus 8 equals the number 10. Now here, we need the absolute value of the algebraic expression by itself. And right now in this particular problem, it is not by itself. This absolute value has this plus 8, okay? And we can't have the plus 8 along with the absolute value. So we have to isolate, get the absolute value alone. The way we can do that is to subtract 8 from both sides, giving us now that the absolute value of x minus 6 will now equal the 2. Now we have prepared our equation because now we have the absolute value alone on the left equaling the positive constant on the right. And from now what we can do is once again set up the two equations. The first equation would read x minus 6 equals 2. And the second equation would be x minus 6 would equal to the opposite of 2, negative 2. Excuse me. As we go now To solve for x, you would add the 6 over, giving us a solution of x equals the number 8. And as we add the 6 over on the second equation, that would give us a second solution of x equaling the number 4. Okay, so here was slightly different because we had to get the absolute value by itself. Okay, and the way we were able to do that is by adding the 8 over to the other side. I'm sorry, subtracting the 8 over. Even if we had a problem like this, let's say we had -3 times maybe x minus 4 equals a -18. Once again, I'm going to recommend that you isolate the absolute value first. We want to get the absolute value of x minus 4 alone, and right now it is not. We have this -3 being multiplied. So to get rid of the -3, we would have to divide both sides by the -3. On the left side, -3 divided by the -3 would give us just the absolute value of x minus 4. Equals, now the right side, -18 divided by -3 would be, of course, a positive 6. And now we have established our equation to read the absolute value on the left and the positive constant on the right. And so now we create our two equations from the one. The first equation would read that x minus 4 would have to equal 6. The second equation would read x minus 4 has to equal the opposite of 6, -6. And so now let's solve. I'm going to add the 4 over. X equals 10 would be one solution. As we add the 4 over, we of course get x equals -2 as our second solution. Okay? So we'll always get the absolute value alone. Okay, whatever you have to do as far as opposite operations. Watch out for the trick questions. For example, let's say we have the absolute value of 3x plus 12 divided by 30 equals, let's say, -5. Now, this is a trick question, okay? It looks scary, but it's really not if you know your rules, okay? Recall what we said at the very beginning when we were talking about absolute value equations. We said that A is the algebraic expression and C is a positive constant. Well, if we were to look at this last example here, okay, we do have a very scary and complicated looking algebraic expression. But what we don't have here on the right side is a positive constant. We have a negative constant. And since we know that the absolute value will always equal a positive number by its definition of a distance, no matter what you try to find out for x, don't waste your time trying to solve this. The fact that it's saying that the absolute value equals a negative number, such as the -5, the correct answer is no solution. Okay, don't try to figure anything out. Okay, the minute you see that your absolute value is equaling a negative quantity, it's a no solution. Okay, it is not possible. Okay. One other type of absolute value equation involves more than one absolute value. For example, let's say we have the absolute value of 2x minus 3 equals the absolute value of x plus 9. Now here we have two absolute values that are equal to each other. Okay, so we are still going to create two relationships. And the first relationship, just like all the other ones, you just drop the absolute value bars, in which case you would write 2x minus 3 equals x plus 9. it's the second relationship, remember, that you always have to take the opposite of the quantity on the right side. So that second relationship is still going to be a 2x minus 3, except now it's going to equal the opposite, notice my parentheses, of x plus 9. So I take the first algebraic expression and I set it equal to the opposite, because remember that negative sign means the opposite of that second algebraic expression. So let's now go and solve for these values of x. I'm going to subtract x on both sides. That would give me an x minus 3 equals 9. As I add the 3 over, that would give us x equals the number 12. That would be one solution. When I go to distribute this negative sign, as I need to do, that would give me 2x minus 3 equals a negative x minus 9. Let's add the x over, because we need the variable x on one side. That would give us 3x minus 3 equaling the negative 9. As I add the 3 over, that would give us now 3x equals a negative 6. Dividing both sides now by 3, that would give us our second solution, that x in fact equals a negative 2. Okay? So the process is the same when you have more than one absolute value, okay, with more than one algebraic expression. All right, you take the opposite of the second side, the right side. Well, we also need to talk about absolute value inequalities. That's the second portion of section 3.3. Now, hopefully, you are comfortable with what we talked about the other day when we were talking about the compound inequalities, because we will have to use compound inequalities, believe it or not, when we are solving absolute value inequalities. Once again, A is going to represent some algebraic expression in the problem. And C is going to once again represent some positive constant, just like before. And I'm going to give you two suggested rules to follow when solving absolute value inequalities. The first rule tells us that if the absolute value of an algebraic expression is less than some constant, then what we're going to say is that the opposite of the constant is less than the algebraic expression, and the algebraic expression is less than the constant. What we have just created is that implied or inferred and compound inequality. So if we have a problem such as this, that the absolute value of some algebraic expression is less than some positive constant, then what we're going to do is we're going to create out of this an and compound inequality that tells us the opposite of the constant is equal to the algebraic expression, and the algebraic expression is less than that constant. The second rule tells us that if the absolute value of an algebraic expression is greater than a constant, then what you're going to do is you are going to say that the algebraic expression is greater than the constant, or the algebraic expression is less than the opposite of the constant. What we have created here is an example of an or compound inequality. So depending upon your absolute value inequality, that will determine if you're going to create an and or an or compound inequality. Now, what if we had that or equal to symbol involved? Okay, for example, what if the problem read, if the absolute value of a is less than or equal to the constant, then we would have to use the or equal to symbols here as well. If the problem read, if the absolute value of the algebraic expression is greater than or equal to the constant, then you'd have to use greater than or equal to and less than or equal to symbols there as well. Okay, so be consistent with your inequality symbols. If it involves the or equal to symbol, you must have it as part of your answer. If it does not involve the or equal to symbols, then you just have to do the less than or greater than symbol. Let's take a look at examples. Let's say for the following we have the absolute value of maybe 2x plus 5 is going to be greater than, let's say, the number 9. We want to now solve this inequality, this absolute value inequality. Well, let's first of all take a look at which rule we have to follow. According to this, the absolute value is larger than the positive constant, in this particular case 9. And I'm looking at my rules here, and I'm saying that resembles rule number 2. So according to rule number 2, I have to take the algebraic expression of 2x plus 5, and that's going to be greater than the constant 9, or the 2x plus 5 is going to be less than the opposite of 9, negative 9. Let's now go and solve this or compound inequality. I'll start by subtracting the 5 over. We want to subtract 5 from both sides, in which case now that would give us 2x is greater than 4. When we divide both sides by 2, we get x is greater than 2. Or, for the second part, we'd have to subtract 5 over, giving us now 2x is less than a negative 14. As we divide both sides by 2, x is less than a negative 7. If we were to graph this on our number line, we would put on our critical numbers negative 7 and 2. Both 2 and negative 7 are not part of the solution, so remember we represent that with open circles. X is greater than 2, we shade to the right of 2. X is less than negative 7, we shade to the left of negative 7. But remember, you will be asked to write your answer in interval notation. And recall the interval notation would go from a negative infinity to negative 7 with parentheses around it, or from 2 to infinity. That would be your solution to that absolute value inequality. Let's try another one. Let's say we have the absolute value of maybe x minus 8 is going to be less than or equal to, let's say, the number 2. Now, once again, we want to establish which rule we're going to have to use. And if we look carefully at the two rules, since the absolute value is less than or equal to the constant, we're going to have to establish rule number 1. And rule number 1 tells me to take the opposite of the constant, negative 2, is less than or equal to x minus 8, and x minus 8 is less than or equal to a positive 2. So here we established and created an AND compound inequality. And remember, with ANDs, a little bit easier, we're trying to get x alone in the middle. So I will have to add 8 to all 3 parts. As we add to the left, negative 2 plus 8, of course, would give us 6. is less than or equal to x alone in the middle, and x is going to be less than or equal to 2 plus 8, the number 10. If we were to represent this on our number line, we start with the critical numbers of 6 and 10. Now, both 6 and 10 are part of the solution. Remember, we have to include them by shading in those dots. And we are looking for the values of x that satisfies both. Where can we find a value of x that's greater than negative 6 and less than 10? Well, of course, that's right here in the middle. Our interval notation, you may recall, goes from 6, the smaller, to 10, the larger quantity. Both 6 and 10, remember, are included in our solution, so we use that different symbol, the bracket. And that would be your solution to that absolute value inequality. Now, there are two special cases that I want to show you. Involving the absolute value inequality. I'm just going to make up two very similar problems. The first problem, the absolute value of x plus 5 is going to be greater than, I just need any negative number, I'll say a negative 8. And then I'm also going to talk about the same algebraic expression of x plus 5, and the absolute value of that is going to be less than a negative 8. So these two problems look very similar. They have the same algebraic expression. They have the same negative number, okay? Because both the algebraic expression and the negative number doesn't make a difference what they are. What matters are the signs here, okay? And let's see why this is. Regardless of what x is, x could be a negative 20, x could be 0, x could be a positive 3. It doesn't make a difference what value of x you plug in, because in the end, when you take the absolute value on the left side, you will always get a positive quantity. And whatever that positive quantity might be, will that positive number be greater than negative 8? And the answer is yes, always. All positive numbers are greater than any negative number. So this would always be a true statement. And whenever we have a true statement left, that's when we talk about x is all real numbers as far as our solution. Of course, the interval notation would go from negative infinity to infinity on our number line. And once again, that is because regardless of what x is, x, no matter what I plug in for x, when I take the absolute value of that quantity, x plus 5, it will always be a positive number. And we know all positive numbers are greater than any negative number. So that's why it's always true and all real numbers. Let's take a look at the second one here. That same algebraic expression of x plus 5, when I take the absolute value, will still always be positive. Will that positive number ever be less than a negative number? And of course, that answer is false. That is not true. And when you get a false statement, that's when we simply write no solution. Okay, so those are your special cases that involve absolute value inequalities. Okay, that completes section 3.3. That completes chapter 3. All right. In our next time around, we will begin chapter 4. And in chapter 4, it is going to be all about graphing. Okay. So if you have graph paper or a ruler, you may find that useful when you're doing the problems or working on your homework. Okay, so like I said, in chapter 4, everything will involve some type of graphing on the XY coordinate plane. There is some homework problems that go along with section 3.3, so give those a try and feel free to email me any questions or concerns that you may have. Until the next time, be well.